Here we are in section 8.3, and we have product to sum and sum to product formulas. Again, if you look at the bottom of my sheet that I sent you, there are the bottom two sections. And just like anything else, this is pretty much just plugging into a formula. And we're going to do a couple examples here. If you don't have my sheet, you should go back and look at some of those emails so you can use these. Let's do the first example here. If I have the cosine 5x times the cosine of 2x, we're going to use the product to sum formula. And there are four of them. And if we look, we can see that this is a cosine times a cosine, so there's only one formula to use. So I'm going to use 1/2 cosine of 5x minus 2x plus cosine 5x plus 2x. And so if I can simplify that down, I get the cosine of 3x plus the cosine of 7x. And to us right now, that doesn't seem better, but these kind of things we can find. In some cases, that's difficult to find. So we're just using formulas to show a different format, and that's what it's going to be. So in this case, we're using the sum, in this case difference, to a product. So if we look on our sheet, there's a sign minus a sign. So again, there's four formulas. Pick the one with the minus sign in it. So all we're doing is plugging into it. So I'm going to say 2 cosine of 5 theta over 2 plus theta over 2 divided by 2 times the sine of 5 theta over 2 minus theta over 2, again, divided by 2. All right. So if I simplify this down, I end up with 2 cosine. 6 over 2 is 3, 3 over 2, so I get 3 over 2 theta, times the sine of 5 minus 1 is 4 theta. 4 divided by 2 is 2 divided by 2 is just theta. So that actually does look better that way. Section 8.4, some trig equations. So if we recall that a solution or a root of an equation is the value of the variable that makes the equation true. So is theta equal to pi over 2 a root of that? So, well, a way to test that would be to just plug in. So let's find out if cosine squared of pi over 2 minus 3 cosine at pi over 2 equal to 0. Well, let's plug in, and we know that the cosine, this means cosine pi over 2 squared. That's what that means. Notation. And the cosine at pi over 2 is the x value, which is 0. 0 squared is 0. 0 times 2 is 0. Minus the cosine at pi over 2 is, of course, 0 again. And 0 times 3 is 0. And I get, yes, that's a true statement just by plugging it in. Well, the idea, though, is to find the solutions. To do this, we employ our algebra skills. So instead of just guessing what it is and then testing it, we're trying to find them. So if I make a substitution, y equals the sine of x, I get 2y squared minus 3y plus 1 equals 0. And we're used to factoring that. But what I want you to be able to do is notice that this is a trinomial in the form of factoring, so we don't have to make the substitution, and we can just factor it in the form of 2 sine x and sine x And I'm going to go with a -1 and a -1 equals 0. And so here, if I set this equal to 0, I get 2 sine x equals 1. Sine of x is equal to a half. Over here, I get that the sine of x is equal to 1. Well, I know that the sine of x is equal to a half. Sine is the y value, so this happens at pi over 6 and 5 pi over 6. The sine is equal to 1 at pi over 2. So we found all the solutions that work in this by factoring it. Let's try to do the same thing here. Well, it's difficult to factor when you have two variables. So what I'm going to do is I'm going to change the cosine into 1 minus the sine squared. Hopefully that will help me. I'm not sure if it does or not, but I'm going to try it. So I get 2 minus 2 sine squared minus the sine minus 1 equals 0. Putting like terms together there, it looks like I'm going to have negative 2 sine squared minus the sine and then plus 1. And I don't like factoring when it's negative, so I'm going to change all of it to multiply both sides by negative 1. So 2 sine squared plus the sine minus 1 equals 0. And then that's similar factoring to the last one. And I'm going to get 2 sine and sine. And I'm going to go with one of them plus. Let's go with this one plus and this one minus. There we go. So outside, outside gives me 2 minus 1 gives me the positive 1. So if I put them over here, I get the sine is equal to 1/2. And we've already done that one. We know that that one's pi over 6 and 5 pi over 6. But the other one, I get the sine is equal to negative 1, and that one happens at 3 pi over 2. So here's our 3 answers for this equation. Now, let's take a look at this one. Holy cow, right? Determine all the real solutions of the equation below in the interval from 0 to 2 pi. Round your answers to 2 decimal places. So, well, the first thing that I want to do here, since it's a cubic, is to factor by grouping. But instead of grouping this with this, I want to group this one with that one, I think. So I'm going to go with 16 sine cubed plus 36 sine. I'm going to group those together. And then I'm going to go minus, because the third and fourth are negative. And so when I factor out the negative, I get 12 sine squared plus 27. And let's see if that works. I think I can pull out a 4 and a sine out of each of those, leaving me with 4 sine squared plus 9 minus, it looks like I can get a 3 out of each of these, which leaves me with 4 sine squared plus 9. Ooh, that's a good sign that they're the same, isn't it? So 4 sine squared t plus 9 times the quantity of 4 sine t minus 3. And if I do a little bit of solving here, set this equal to 0, I get sine squared t is equal to negative 9/4, square root, and I get the sine of t is equal to the plus or minus 3I over 2, and those are imaginary, so I get no reals in that. But over here I get sine of t minus 3 equals 0, so I get the sine of t is equal to 3/4. And I'm going to just leave it like that. But where is this answer at? Well, the sine is the y value, so at 3/4 I'm going to be somewhere there and somewhere there, because that's about where 3/4 is for a y value. So those are the two places where it's going to happen. Let's stop there and we can do section 5 by itself.